All right, so today's date is Friday, January 31st, and I'm teaching our first ever lesson of BC Calculus. So we're on BC Calculus 1-1. I'm talking about parametric functions today. Our objective is to do what, Chris?
Graph parametric functions by hand.
Yeah, so because I don't have enough of the nice calculators that Geo has, Geo show it off. Yeah, it's the TI-89. We only have the TI-83 pluses. I can give you guys the TI-83 pluses, but because you guys don't actually start doing real AP calculus until next year, you guys are going to be using Desmos, and you'll love Desmos way more than that cringy calculator. So sorry, Geo. You can use Desmos to Geo if you want, but I highly recommend, especially you, Stego, and Arrow, and Claire, if you're watching this, to just use your TI-89 or 83 plus if you're Arrow. Okay, so...
No, if I'm going to do this, does that mean I don't have to?
Yes. All right, so the whole idea is parametric functions. We are going to be able to break one of the rules that I taught you in Algebra 1 today. The vertical line test, we get to beat that guy up and he doesn't exist anymore, at least when we're in parametric land. All right, so usually when I have a normal Cartesian function, I would have an input that's x and my output would be y. Now my input is t and my output is x and y. I'm going to feed in a value of t, so this is a parametric equation right here that I've given you. I'm going to feed you in a value of t, and you're going to get out an x and a y. So, because we need two outputs, we have an x and y, therefore we need how many equations? You guys can hold up your fingers. It's not 3, it's 2. Yes, it is 2. We need two equations, and there they are. Look, x is equal to t squared, x is equal to t. I could do whatever I want here. I could say cosine of t plus 3. I could do the square root of t. I can put whatever values I want, but now I have to have a table. Instead of x and y values, it's a table of t, x, and y. And I took the liberty of giving you guys some t values to check. And if you've never seen these before, you have no experience, just plug in random values. My random values, I went from -3 to +3, stepping by 1. In the next example, you don't know what values of t to choose. Eventually you'll figure out, ooh, these values make it come out to something that I know. But for now, yes, I gave you your values of t. You're eventually going to have to pick your own values of t. So if I pick a value of -3, what is x with a quiet raised hand? Geo.
9.
Perfect. If I choose -2, what is x? Someone else. Andrea. 4. If I choose -1, James, I get 1. If I choose 0, Eva, I get 1. If I plug in 0 as a value of t into our equation that's talking about x, 0 squared is indeed 0. And Fiona, next one is Arrow, the next one is
4.
and Stego, next one is 9. Okay. So those are our x values, and then let's find our y values. It's the exact same values, just copy them down. -3, -2, -1, 0, 1, 2, 3. And then I'm going to graph 9, -3. I'm going to graph 4, -2. These are now your old-fashioned coordinate pairs. So graph 9, -3. Okay, 9 is right here in between 8 and 10, and -3. So there's 9, -3. 4, -2. 1, -1, 0, 0. Keep graphing these. I know that there's an axis of symmetry happening here because I can see what's happening. I have, wait, that goes, I was doing this wrong. There it is. -1, there it is. Wait, -1, 1, no. There it is, Jesus, okay. Jesus, take the wheel. All right, I have all those points graphed. Check your graph with my graph. You might notice this shape. Does it seem familiar to any of us?
Yes.
What is the name of that shape with a quiet raised hand? Starts with a P. It dealt with quadratics back in Algebra 1, or we reviewed it again in Algebra 2. It is not a pyramid, and there should be a quiet raised hand next time, Christopher. It's a parabola. It's a sideways parabola, so we can label it. This is a parabola. hopefully I'll give you enough problems tonight where you'll be able to see kind of what's going to be happening with different shapes. So it's a parabola, it's a sideways parabola, so if I were to sketch my graph, it should not be a sharp corner down here, but a nice gradual curve. Then it comes out this direction. And notice that if I graphed 4, I should go out to 16, so that's another hidden point that I can have out there. It's a parabola that goes on forever and ever that direction. A parabola that comes out in this direction. It goes through that point down here. So I have this sideways parabola. And I'll wait for you guys to finish graphing this. But this is unsettling. Why is it unsettling, Mr. Siddell? The vertical line test says that this is not a function. And it's correct if I'm talking about a Cartesian function. But this is a parametric function, which means the vertical line test, which used to say, hey, if I draw, that's not a vertical line here, it should only be able to touch the function once. It can now touch the function twice. And it can touch the function technically an infinite number of times now. All right, so that was the parabola. We're okay. No questions yet? Let's move on to something that's a little bit harder. I'm going to give you a different shape now. Your x is cosine of t, your y is sine of t, and I've given you a slightly different graph. I've given you the x and the y coordinates of a half, square root of 2 over 2, and square root of 3 over 3, and 1. Why did I do that, I wonder? I wonder if anyone can connect the dots here. So choose a t value. The first one I'm thinking of, 0. Like 0 and 1, those are usually the nicer numbers, right? So if I plug in 0, oh, cosine of 0. All right, everyone point to 0, first of all. Cosine of 0 is, boom, out to the right. Now cosine is at the x and the y coordinate.
X.
What is the x coordinate of straight out to the right? On a unit circle, everyone's going to hold the number 1. Straight out to the right on a unit circle. Unit circle means I have a distance of 1, my arm has a length of 1, and the x coordinate is 1. So, my x coordinate is 1. Let's talk about sine of 0. Again, my arm is out to the right because my angle is 0. Sine is talking about the y coordinate. I haven't moved up or down, so my y coordinate is 0. So, 1 comma 0. Let's graph this at the same time. 1 comma 0 is right here. I wonder what's going to happen here. All right, so now let's choose another t value. And you have to choose a t value that's nice. Remember, when I choose a value of t, because I'm talking about cosine and sine, I'm really choosing an angle here. What's a good angle? I'll give you a bad angle. 1. 1 is a bad angle because I don't know what cosine of 1 is in my head. You should be able to do these in your head. Choose a number that is nice. Cosine of something. You can do degrees or radians, whatever you want. 2, I don't know what the cosine of 2 is.
1/2.
I don't, what's the cosine of 1/2, Gio? I don't know. Yeah, choose something that you know. Boom, there it is. Pi. Cosine of pi. And let's stay in radians now because we are in AP Calculus. AP Calculus, we're just trying to stay strictly in radians. If I do pi, everyone point to pi. To the left. Pi is straight out to the left. What is the x coordinate of pi?
-1.
-1. We're going to shout these ones out from now on. What is the y coordinate of pi? Y coordinate of pi is 0. Graph this one. -1, 0 is right there. Huh. This is kind of interesting. When we graphed pi, we actually put the point on the unit circle for pi. I'll choose another nice number, another nice radian measure.
-5. No, just kidding.
Negative pi is the same thing, so let's sit out to the left.
Pi over 2.
Pi over 2! All right, let's do it. So if I choose pi over 2, everyone point to pi over 2. Straight up, all right. And what is the x coordinate of pi over 2? What is the y coordinate of pi over 2? 1. Graph 0, 1. Wait, I graphed that last one wrong, didn't I? That one should have been at... Oh, I did it again, right here. Okay, now I have them correct. All right, what's another really easy one that I can check? What's the one that points straight down?
2 over 5.
Pi over 2, no.
3 pi over 2.
3 pi over 2, yeah.
It's a linear.
3 pi over 2 is straight down. 3 pi over 2. 3 pi over 2, that's going to give us the coordinate x is 0, y is -1. we come down here and put a point. I wonder what shape we can get. Do you think we can maybe get a triangle? Do you think we can get some weird oval thing? I wonder what shape we're going to get here. So we're still not clear. We need more points. So choose something else that's nice. And as your hint, I'm pointing to your special right triangle poster in the top left of my cubbies up there. You're going to need those now. Choose another angle.
Pi over 3.
There it is. Pi over 3. Pi over 3. This one is a little bit harder now. Everyone point to pi over 3. Pi over 3. Well, we know that all of pi goes all the way out to the left. So cut that into thirds. Chunk, chunk. There's 2/3. There's 1/3. 1/3 is not straight up, a little bit to the right. So there's pi over 3. So if I was doing pi over 3, that comes out this direction. And notice that's going to be an intersection point on our grid.
It's the middle one, right?
Pi over 3 is right there.
I can remember.
But how do I know that? What is cosine? I'm doing the x, right? What is cosine of pi over 3?
What happened?
Cosine of pi over 3 is 1/2.
What?
Cosine of pi over 3 is 1/2. And these are things that we memorize at the very beginning of the year, so you should hopefully still have these memorized. And therefore, sine of pi over 3 is square root of 3 over 2.
James, is it going to be a circle?
It is going to be a circle. Yeah, you already see it, Eva. So we just graphed that point. If I graphed, what would give me this point right here?
Pi over 4.
Pi over 4. And I can show you. Pi over 4. Put it in here. Cosine of pi over 4. Everyone point to pi over 4. It's that 45-degree angle. Boom, out to the right. And yeah, it's square root of 2 over 2, 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 and it's that point right there. We get a point right there. And you should see that all of these points of intersection are now going to be on our graph. And Eva had it correct. This is indeed going to be a circle. All right. So let me ask you to predict something. What do you think would happen if we switch this so that x was sine and y was cosine? What do you think the shape would be? You'll figure it out on the homework. But that's all I have for you. There's no backside to this.
It's definitely a square.
So how do you graph this on the calculator? And I'll show you that really quickly. I don't really have, maybe I should have calculator section. I didn't really think about this ahead of time, and I should have. The calculator. In terms of a calculator, how do you enter x is equal to cosine of t and y is equal to sine of t? The way that we do this, at least on Desmos, is as follows. And let me check this to make sure I'm doing it correctly. So Desmos.com, start graphing.
What do we do?
I want to graph this thing on the calculator, this exact function to check our work. How do we do that? And the way is you just enter the x. So normally you do x comma y, right? So the x was equal to cosine of t. And we have sine of t. And then what are our bounds for t? I'm going to say from 0 to 2 pi. And I guess I can turn projector mode on. We have checked our work. There it is. Usually you want to go from 0 to 2 pi unless something is happening weird in your bounds here. It's usually always going to be 0 to 2 pi, and sometimes it's 0 to pi. Notice if I do 0 to pi, it only goes to pi and then stops. So 0 to 2 pi. What do you think is going to change if I change this to 4 pi?
It's gonna get bigger.
Going to get bigger? Nope. It just went around the circle twice. All right. So you know how, like in terms of the notes, you need to say, just turn this into cosine of t comma, sine of t. In terms of a calculator, I have the instructions on the worksheet. So if you're using the TI-89s or TI-83 pluses, just pay attention to the instructions in the worksheet. If you're doing Desmos, you can ignore those instructions because you aren't doing that quite yet. All right, that concludes our first BC Calculus Lesson 1-1. Give me a fist, thank you. Give me a fist of 5. How well can you do our objective today? How well can you graph these both by hand and on the calculator? Let's go around. 4, 4, 4, 3, 3, Teflon. 3, 4, 4. Is that a, what is this? A 4, okay, thank you. All right, thank you.